see some questions about the basics of the equilibrium we discussed in the previous video. What are the two types of chemical reactions discussed in the video? What are the two types of chemical reactions discussed in the video? Fast and slow reactions, irreversible and reversible reactions is the answer. Equilibrium and non-equilibrium, oxygen and carbon dioxide reactions, no. Always make sure you know that all the options are checked. Which type of reactions only proceeds in one direction? The irreversible ones. In the example given, he's talking about the example between nitrogen and hydrogen. No. About carbon and oxygen to free carbon dioxide. Which reaction is considered as forward reaction? No, he's talking about the reaction between N2 and H2 to form NH3. Balance it for sure. The reaction between hydrogen and nitrogen is the forward one. What is the first possible case in reversible reaction? The rate of the forward action is faster than the rate of the backward action. It's not necessary, but this is the first one we discussed. The second one was when the backward was faster, and the last one is how is equilibrium represented in a reversible reaction with a double-headed arrow. This is the symbol that we used. We have some more MCQ questions. What is the definition of a dynamic equilibrium? It's a reaction in which two reactions happening simultaneously in opposite direction at the different speeds? No. At the same speed or rate? Yes. In the same direction? No. In opposite direction at the same speed? No. Which of the following is an example of a microscopic change in equilibrium? This changes in concentration is considered as macroscopic. Changes in pressure, changes in temperature, anything I can measure is considered as macroscopic. Microscopic is I don't see like the binding of molecules. This is the only correct one. What happens to the macroscopic properties in dynamic equilibrium? The macroscopic properties don't remain constant and don't change. In which type of system can equilibrium occur? Only in open systems? No. In closed systems. Steady state system is not a system in equilibrium, it's a system in equilibrium but in closed system. Open and closed at the same time? No. When does equilibrium occur in a reversible reaction? When the rate of forward and backward reactions become equal. When product concentration is higher than when the reactant completely converts into products. Equilibrium never occurs in a reversible reaction. This is wrong. I have some more questions for you. In equilibrium, how many reactions are happening simultaneously and in which directions? We explained this already. Two reactions happening in opposite direction. Don't say one reaction, don't say three, don't say four. What are microscopic changes in equilibrium? These are changes that occur such as binding of molecules or breaking down of compounds and chemical actions that you cannot see or measure. Which of the following is an example of microscopic change? The formation of ammonia from nitrogen and hydrogen. I cannot see this one. The changes in concentration I can measure. Steady state systems is not related. Changes in color I can measure. What happens to macroscopic changes in equilibrium? They stop and remain constant. Equilibrium can only occur in which type of system? Again, we say it's enclosed system. What does the reversible direction of a reaction indicate? Equilibrium has been achieved. The reaction is initially started. The rates of forward and backward action are equal. The concentration of reactants and products are constant. So a reversible direction of a reaction indicates that equilibrium has been achieved, or rate and forward and backward actions are equal, or action is initially started. When you say reversible direction, which means happening in both sides, concentrations are constant, rate of forward and backward are equal, and equilibrium has been achieved. How can the concept of equilibrium be visualized? Through a graph. This is the graph that I will see, and I can see that the rate of the concentrations decrease and the rate of the products formation increase, and then suddenly they become equal. This is where they are equal, as we explained in our video. We can write this through a chemical equation and through a mathematical equation that we'll take now. Now, what is the next question? What does the x-axis represent in a graph of equilibrium? The x-axis is the concentration of reactants and products. or time? No. This is only the concentration in y-axis. The time is in x. Temperature and pressure is not correct. How do the concentration of reactants and products change over time? The reactants concentration decrease? No. They both decrease, they both increase. The reactants concentration increase and the products concentration decrease. The reactants decrease and the products increase. What does it mean when the rates of change of reactants and products become equal? Equilibrium has been reached. Reaction has stopped. No, don't say the reaction has stopped, because we said the microscopic still keeps going on, the binding and the breaking down. Action proceeding in forward, action is proceeding in the backward. This is when the rates become equal.